Welcome back. Your next challenge is called Waiting Room. There's a waiting room with n chairs set in a single row. Chairs are consecutively numbered from 1 to n. First is closest to the entrance, which is the exit as well. For some reason, people choose a chair in the following way. Number 1, find a place as far from other people as possible. Number 2, find a place as close to the exit as possible. All chairs must be occupied before the first person will be served. So it looks like this for 10 chairs and 10 patients. And it's kind of hard to read the dark blue color here. This says chairs. And so they're naturally ordered 1 to 10 from the entrance and moving away from the entrance. And then they show you in this row, the patients, the order that they would be seated. So the first guy comes in, all seats are empty, right? And this guy or gal sits right here because it's closest to the exit. So you can think of it as favoring to the left. Number 2 comes in, and because of this first rule, find a place as far from other people as possible, naturally they're pushed to the other end, which is spot 10, the very end, right? And so that number 1 priority pushes them all the way to the end. That's the farthest away while being closest to the exit. And then number 3 comes in, right? And so you have this chunk now that's open from 2 to 9. And so to find that place as far away from other people, they have to be in the middle of this empty set of chairs, right? That should be very clear. And note that they're going to be slightly closer to person 1 if they sit in slot 5, which you see they do here because of the 3's there. They could have sat in slot 6 to the same effect. There would still be 3 empties from one person and 4 empties to the first person. But it's the same effect here as when they sit in slot 5, because they're 3 away from that one and 4 away from the person on the other end. But remember, it said that's when this rule number 2 kicks in and says find a place as close to the exit as possible. So they chose to sit in spot 5 over spot 6. And then you can imagine this would proceed to the 4th patient coming in. And because this empty section is only 3 chairs, and this empty section is 4 chairs, there's a bigger empty chunk to the right, they will find a spot to the right. And again, they could have gone to 7 or 8 to the same effect, but because of rule 2, that kicks in and pushes them to slot 7. So hopefully, go ahead and work it through all 10 patients if that's not clear yet. But basically, once the ends are filled up, they're always going to find the biggest chunk that's open. And if it's an odd number of seats, they'll sit right in the middle. If it's an even number of seats in that chunk, they'll favor the one slightly to the left towards the exit. And your task is to find the last patient's chair number. Input, the number of chairs n is an integer greater than 2. And the output is a positive integer, which is the last patient's chair number. And you'll note the numbering's from 1 to 10. We know in computer science, typically indexing's done would be 0 to 9 in this case, but we're using 1-based numbering. Have fun. So go ahead and try this one out. Pause the video, resume when you're ready for a solution. So I'm going to get rid of this. Now, before I even go into writing code, I think it's helpful to consider a couple other examples, because the trap you may have fallen into here is that, they've constructed this little scenario, they've got rules, you've got your section of chairs, and it seems like there's more going on than there actually is. And so it's easy to think that more complexity is needed than actually is. And I think this is made clear if you look at a couple other examples besides just the 10-chair example. So consider the example, the base case, right, or the really simple example that there's only 2 chairs. They told us it'll always be an integer greater than 2. Well, I suppose if they say greater than 2, it would be at least 3, but it doesn't hurt anything to consider 2 as well. So you got how can I depict this? I wish I had a little area I could draw. Maybe I need to start incorporating something like that. But my underscores here would be the seats, right? The first guy comes in, he goes there, 1, right? And then the second person comes in and there's only 2, right? And we see that, let's find the last patient's chair number. So yeah, I see why they do it greater than 2, because the last patient's chair is the last chair. So scrub that example. Let's do 3. So the first person comes in, right? We know they sit close to the door. They have their pick. Second person comes in, they go to the end. They want to be as far away as possible. The only thing for the last patient is to go like that, right? So let's do another example. And I'm going to do a few of these just with the idea that I hope you can see a pattern forming. First person comes in, takes first seat. Second person comes in, tries to be as far away as possible. Third person comes in. It's the same effect for either open seat, right? But they say favor the entrance exit. And it goes like that. Last patient is 4. Last patient here was 3, right? Try it again. 1, 2, 3, 4, 5. All right, you know, first patient goes there. Second is there. We've got an odd number of empty seats, so the third person can go there. The fourth person will favor the entrance exit, and the fifth will favor that. Let's do one more example, and I think that's enough to see the pattern that's forming here. Plus, we have the original example. First patient comes in. Second wants to be as far away as possible. Third could go to either of these, so we go to rule number 2 to decide it, and they favor the entrance. Fourth comes in. It could be either of these according to rule 1, but rule 2 demands they sit there. Finally, you get the next person that comes in and they favor the entrance, and there's only 1 seat left. So what do you notice in this pattern that's growing here, right? There's your last, there's your last, there's your last, there's your last. What was it in this example? Every time it's 1 off the end of the collection, right? It's just 1 back from the last seat is where they always end up. So I think this problem is as simple as n-1. We'll get rid of this. Okay, let's green and green. Yeah, so I'll go ahead and submit mine like this. Hopefully you didn't fall for the trap and do a bunch of extra work kind of simulating people grabbing seats, you know, make a collection of seats and fill them in. I mean, you could do something like that, but this is a lot less work. So don't be fooled. You get presented with problems and you naturally think, well, it's a problem. It's got to be, there's got to be some kind of complexity, right? There's got to be some amount of work involved. And well, not necessarily. Sometimes there are big shortcuts you can take. And we've seen that with some clever solutions and other problems. I think I remember back to the one where you sum consecutive integers, and there's a nice formula for that where it's n times n plus 1 over 2. It's really nice shortcuts. You don't have to actually perform all the additions. You can just do that, enter the values into that one formula and get there quick if you know that. So not much going on code-wise, but hopefully this was helpful in terms of analyzing problems and not necessarily jumping right into code, but working through some examples, trying to find a pattern first before just diving in and typing code. I'll go ahead and submit. And yeah, go ahead and look at, yeah, that's pretty popular. So you can check it out, see if there's anything else to learn from people. Otherwise, yeah, hit me up in the questions, comments, or we'll keep going to another challenge. Thank you for watching.